Welcome back to episode 8. If you remember last time we had Kimby here on the surface of Minmus, and we are in fact in a very good place to just basically burn straight up and go home. If we just go straight up from here, we're basically in the right position to completely negate all of our velocity that we got from being on Minmus, which was a complete coincidence. I did not plan for this at all. And this is probably the least efficient way to do it, basically burning straight up against the gravity. But we have so much thrust and so much delta V, and Minmus has such low gravity that it doesn't even really matter that much. I mean, we could probably go back into a circular orbit and then return to Minmus with the amount of fuel left in this. Maybe I exaggerate that a little bit, but we have a lot of delta V at this stage. So yeah, just burning down now. You'll notice I'm not changing my direction at all. And the bottom half of the nav ball has been cropped off, which is a problem with my video recorder. I just switched over from using a generic screen recording into OBS Studio, and so I'm having some troubles with the resolution there. So apologies for that. But we've overshot a little bit, so we have to kind of point back and just get ourselves on a nice re-entry course here. It's all par for the course. And just getting it down to about 38-ish kilometers, which should be not steep enough that we're burning up, but so that we don't skip out of the atmosphere entirely. And yeah, basically just straight up, and now we just watch Minmus fall away. There it goes there. And we will eventually begin our long fall back into Kerbin, all the way down there, admiring the view of the two moons of Kerbin in their celestial ballad. We have plenty of life support, but as we go down and as we exit the sphere of influence, something happened to the vessel here with its power.
Oh, our electric charge should orient those solar panels. Yeah, that would be a problem. This thing only has 4 hours of electricity on it, so we don't want to lose it. Oh, why am I losing my electric charge? That is odd. Energy flows 0. Where is this going? What's happening? I'm charging. Is this like a persistent rotation thing? Let's let it stabilize. I'm not sure why my electric charge was going like that. I'm gonna point my camera at Kerbin now. Yeah, my electric charge seems to be fine. Not sure what that was. So now, 42 minutes from periapsis. We're just gonna... We might actually come down pretty close to the Space Center with this approach that we've got here. Although I suspect we will be overshooting by a fair distance.
And yeah, the entry was pretty standard. We did lose that camera on the way down, although we didn't really need it to begin with. And going through the re-entry, it was a little bit of a balancing act to keep pointed on the marker so that we didn't overheat. But we made it through just fine. Deploy the parachutes on a nice sunrise, the pre-dawn skies, and come down for a splashdown in the ocean east of the Space Center, 20 meters, carrying our precious payload of science. And just how much science did we get? Oh, doing a bouncing act here. Just how much science did we get from that? 1,000 science. This is lots. This is going to allow us to unlock only 4 nodes, unfortunately. So I have to pick and choose carefully. So we can take those, and then we can take 4 more of these upper ones. So I go for the bigger capsules, and now I have a bunch of choices between me. So I could get some fuel systems, bigger engines, bigger fuel tanks, more generalized construction applications, some docking and robotics parts. Also a lot of things that we can make planes out of. But eventually I decide I'm going to go for these improved electrics, so, batteries and solar panels and the like, some of the specialized construction, because that gives us the more powerful relay antenna. I could get the scanning tech for more science, but I want to kind of go tier by tier here. Some procedural plane parts from B9 and other airplane and wing bits. And then it's a choice between fuel tanks and engines and whatnot. There's some interesting parts here that I've never encountered before, quantum thrusters and things. But yeah, eventually, it's just between some engines, fuel tanks, looking at the science experiments that we could unlock, cooling systems, and all of that sweet, sweet stuff that will help us build more cool and awesome spacecraft. But eventually, planes, fairings. Nah, I think the choice is probably going to be bigger fuel tanks and then some of these high-performance engines. Now, with those high-performance engines and the new antenna that we've unlocked, it's time to upgrade our communications system. So you can see here, because of the somewhat lazy approach that I took before, they've all kind of drifted out of that wonderful hexagonal arrangement that they were in. So this is the exact same launcher, featuring 3 of the same satellites. However, they are now equipped with the bigger relay antenna that we've unlocked this time, instead of the deployable high-gain one. However, because this is the same launcher, it does tend to suffer from a lot of the same problems. So this first stage gets us about 20 kilometers up, and we wait a while before staging, but it does not help. And we flip around worse than ever before. I think because those new antennae are so heavy, the center of mass is now even further forward, and so this thing really just does not want to be stable in this regime, even though we are 30 kilometers up. But, the normal approach doesn't seem to be working so well, so now my problem is just not losing all of my vertical speed, because I do not want to start falling. And we can't keep it there. So if this thing does start falling back to the ground, that would be really bad, and it would be basically unrecoverable. So these little bursts are just going to have to do until we can get where the air is thin enough that it does not want to just, tip around and flop all over the place. And maybe this time, yep, okay. Now it seems about 36 kilometers, it seems, is where the air is thin enough that the gimbaling can actually overtake the aerodynamic forces. I really need to rework this launcher. But there's still a ton of delta V in this thing, and with it we'll be able to get back into our Kerbo-stationary parking orbit. This time, we'll probably end up using most of the fuel in those upper stages. I'm also going to go into a slightly inclined orbit because, maybe in the future I'm going to do something polar, and it would be nice to have a little bit better connectivity around the poles of Kerbin. So go into a standard, just directly up into that orbit there. I'm not caring so much about maintaining connection with the Space Center directly, because these are powerful antennas and we've already got the workings of a relay here. So just getting our solar panels oriented, you can see those 3 static antennae there that are designated stronger transmission and designated for relay purposes. This time we don't have enough fuel in that stage to actually complete our circularization, but we get there the rest of the way with that little upper stage that could. And I'm going to be a little more careful about my orbital period, but those decouplers are pretty strong, so there's not a whole lot that I can do about it. And same procedure of changing the period back down to 4 hours, waiting to go a third of the way around, and, all of that stuff we've seen before. This time, though, there are a lot more green lines, which is a good sign. It means we have more connection with all of the different satellites. These 3 should be a pretty good support for everything near Kerbin that we do, and maybe even a bit of the way interplanetary. I'm not sure how strong these antennas will be able to reach. I don't suspect they'll be able to take it too far, but they will be a good first step. You hear all the music jingle-jangling at 4 times regular speed here. And as we get the last one into position, do a little bit of inclination change so it's in the same plane as the other three, or as the other two of its siblings. And we have just getting circularized, and we get ready to ditch that last one there. Hopefully that stage will deorbit itself there. But green lights across the board, and we have our communications network.
And here we have our latest innovation, a spacecraft that will take us to the sun. I have to fix my scroll wheel. All right. So this is our largest rocket yet. We keep building bigger and bigger rockets to go further and faster. This one is going to go to the sun, right over there. It's going to go, we're going to try to get this thing near the sun and get the science from there, which will hopefully help us along on our expeditions. So we immediately fly off the pad here. We've got those beefy KW boosters on the side there helping us along. We'll start turning a little. I don't want to go too shallowly. And those are burning very quickly, but they're giving us a nice kick that will help us get a good chunk of the way out. There we go. So now we're just on that main engine there, that skipper, which is not going to get us into orbit, but should get us at least suborbital. And then we have the newly unlocked Poodle here, very high performance engine that with this stage should give us about 5 kilometers per second to work with, which I think should be plenty to get us to the sun. Not really basing it on anything, just kind of guesstimating my way along. So we're now a good 12 kilometers up. Just trying to see the plume expand. I think we will be just fine to get us into orbit with this. I do want to get a good amount of altitude before we get on that upper stage though, because I'm not sure how the aerodynamics are going to play out. And I want to avoid a situation of flipping around with our communications launcher. So we've still got another 500 meters per second on this stage. I'm going to start pointing us upwards just to get some vertical speed and so that our trajectory doesn't go too shallowly. Looking good so far. Another 300 meters per second. I think we'll be fine with this. And the last bit of our fuel here. We'll point back along the prograde vector. And at 32 kilometers. So I'm going to coast us a little bit before getting rid of that and going onto our Poodle.
So the Poodle engine is comparatively low thrust, but has a very high efficiency, about 380 seconds specific impulse. Now, the thing with specific impulse is it is measured in seconds, which is kind of unintuitive, but really what it means is that if you take your engine and you ignore the actual thrust production and mass fuel consumption rates and all that, and you imagine you have 1 kilogram of fuel, and you're going to produce 1 kilogram force of thrust with this engine, how long would the engine be able to do that? So the Poodle would be able to produce, with 1 kilogram of fuel, 1 kilogram force of thrust for about 380 seconds. And of course, the longer your time is, or the higher your specific impulse is, that means you have a much more efficient engine because you can do more. You can produce thrust for more. You can gain more impulse with the same amount of fuel. Now, because of the actual rocket equation, when you look at it, your specific impulse is multiplied by a natural log, which means it's in the exponent. So if you have a very small increase to your specific impulse, that can become a very drastic increase in your actual delta V that you can get out of it. Which is why having such a high performance engine as your upper stage tends to be a very good choice. Although it does usually come at the expense of mass, even though you get much longer burn times and better performance out of it. It's more common for upper stages because they have more room to burn for longer. So what I did there is just a quick apoapsis burst to maximize the Oberth effect. Of course, that when you're moving faster, you gain more kinetic energy out of your engines. And then we just start the long burn to get us on an interplanetary trajectory, burning on the day side of the planet here so that we can nullify our velocity relative to the sun, all of the orbital velocity that Kerbin has. And that way we can drop our solar periapsis until we get nice and close. And we have burn out of fuel there. And now it's time to ditch that for the last kick. And we can just warp on out, orient our solar panels, and then we can just warp out into interplanetary space for science.
Time for the first batch of science. Materials Bay. Something is starting to boil. Hopefully not anything important. There's no fuel left on this. As the hours turn into days, you begin to think the goo is conspiring against you. Well, there's not a whole lot I think it could do. I mean, we're kind of stuck in this one together. Measuring the temperature seems to be impossible. Okay. So now, collect everything. And we can now start to transmit that data back, which conveniently saps all of our power away. But as we get closer, we will start to get a lot more electricity out of these solar panels, because we should probably transmit these based on what is the smallest, I suppose. But as we get closer to the sun, luminosity follows the inverse square law. So if you have your distance to the sun, you don't double your amount of radiated power, you quadruple it. Now with solar panels, of course, because they're made of materials, there are some concerns that happen. As solar panels get hotter, they actually stop working as well. But that I don't think is simulated in the game. It just doesn't calculate the actual heat, I believe. Did that transmit? That did transmit. So what I'm going to do here is it allows partial transmission, which means that we don't need the full charge of power to transmit the data. And now transmitted pressure, and now we just have the material study, which is the largest one.
And yeah, this takes a very long time to transmit. We have to wait for those solar panels and our batteries to charge, and I neglected to put a lot of electric charge on this because I honestly forgot about the very large power consumption needed by the antennas in the stock version with the without real antenna. I've been doing a lot of realism overhaul on the side, and so I've gotten pretty used to the real antenna mechanics, which have and the Kerbalism ones too, which have experiments that are not instantaneous, take a long time to transmit. You have to, plan your antennas, and they have a certain amount of power draw, but your solar panels, constantly making up for it. It's the stock mechanics are something that I've gotten a little rusty with, and so I've forgotten. But yeah, now that it's all transmitted, we just set an alarm for periapsis, and that way we'll be ready to collect science once this thing makes its closest approach to the sun. And there we are.
So here we have our latest creation from the spaceplane hangar, a next generation of science planes powered by these two interstellar turbofan engines. So the surface speed is hard, like concrete. It could be good to land at. That is the only sample that we have actually not collected from the runway. We have everything else. Now, conveniently enough, if we just drive off the end of the runway here, there is the shores, which is a biome that we've not collected any data from. So we're just going to quickly go off to the side here. Actually, help us with the engines just a little bit. And we have this little piece of landing gear on the back here to help us avoid tail strikes, which is going to be very helpful. Let's not go too fast down the hill. And I think this is now far enough away from the runway. Let's see. Yep, we're in the shores, which appear to have a blue liquid nearby. How fascinating. Surface sample. It's very muddy and sandy. There might be water nearby. And it's time to stretch our legs. Yep. So we get back in. The other thing we have here is the sensor package. So we're going to open materials bay, and we have this little service bay here containing some more science. So we'll log the temperature, just the right temperature for a swim. Log the pressure, and conduct materials study. Oh, hopefully we can fix that. Observe the mystery goo. Accumulates near the water-facing side. And now we have this container here that stores all of that data. And we'll just close those back up. Although actually, because Angie is a Kerbal, or is a scientist, of course he's a Kerbal, what am I talking about? Because he's a scientist, he can actually restore these. Restored. Go ahead and close that back up and get back inside. Come on, Angie. You can do it. And board.
Now it's just a matter of wheeling this thing back onto the runway, and those turbofan engines are loud. But I have figured out my volume settings, and now I have, good audio control in my editing softwares. So never again will we have the problem of me, being blasted over by the engines. We didn't have the problem of getting back on the runway, but it was pretty simple. And now we just accelerate down. We have a bit of landing gear on the back there to prevent the tail strikes. And this thing flies actually pretty well for something I skimped out on the Ferrum Aerospace analysis for because I was feeling lazy. So my plan is to go over to the grasslands. The problem is they are very hilly and uneven, so I'm going to scout around until I find a suitably flat landing spot. This thing is remarkably stable. I mean, normally when I build a plane and I time accelerate, it wants to just pitch down. But this one holds pretty good. So we've identified a nice flat strip of land here, and now gear down, engines off, going pretty fast, about 150 meters per second, and that's a little fast for my liking. So just, gliding over, flaring to bleed off some speed until finally we're ready to attempt a landing on this hillside here. And coming in now, 100 meters per second. Go on, flare the nose, kill that vertical speed. I think there's a bump, and oh, and we have, wow.
Well, that was interesting. Well, he survived, and the equipment is still there, and we're in the grasslands. So it's not a lost cause. So why don't we just do our science? I think we are in one of these cities that is appearing here. And we are rotating. If I let up the brakes, or if I turn off SAS. I think this thing is just trying to orient itself down the hill. It's not a problem, as long as it stops. So we're gonna collect the rest of our data from here. Temperature, Pressure, a fine day on the plains. Shape of a leaf. Temperature is quite pleasant. Not sure what's going on with this spinning. If I just let it... Whoa, whoa, whoa. Okay, I won't be doing that again. I think he's just going to have to wing walk. Even as it rotates. Surface sample, EVA report. Yep, looks like dirt. Collect... Actually, we don't need that. What we want is... We want to... Where is my storage unit? Somewhere in there. Collect all. And I don't think I want to try flying this thing, so we're just going to recover it. Because the center of mass should be somewhere about here. But this is an interesting design. We will have to do some research into this configuration of a flying vehicle.
But with the data that we recover from this mission, which is just enough to push us over the edge to unlock one final node, we're going to go for the big heavy lifting engines, but we will have to see those in future episodes. Until next time.